I'm not quite sure why I want to do a video of this, but I've always been curious to know how much quicker a kettle boils when you fill it with hot water from the tap rather than filling it straight from the cold water tap. And like, people in the UK have always had a bit of a sort of thing about filling anything with hot water, because in the past hot water came from a tank that's most likely in your attic and most likely was full of crap and all sorts of rubbish. But that's not the case anymore. You know, we just have boilers like anybody else, and filling it with hot water is fine. It gets boiled anyway. So I'm going to do 2 timed experiments. I'm going to fill the kettle full and time it with cold water, time it with hot water, and then do a bit of maths around how much energy you can save and how much money you can save by filling it with hot water. Of course, you use gas filling with hot water, but we'll try and do a bit of maths around that and see what we can come up with. 24 hours later, I had to abandon that project last night because not because it's dull and weird, but because my girlfriend came home from her work Christmas do in a bit of a state. And she basically, well, you can't start recording videos of how quickly water boils when your girlfriend's come home drunk. It just doesn't, I don't know, the two just don't go together, do they? So we're gonna do it today. And here is the brilliant setup that I have here, the very scientific setup. We have our kettle and we have our timer here on the iPhone. And I'm gonna fill this to the top, to this max line here, or actually to this red marker that you can just about see in there. And I'm gonna do that with hot water, and I'm gonna do it with cold water, and we're gonna time them both and see how much difference there is. Now, let me just check the power rating of this kettle, because that will obviously influence our maths here. Okay, so it's a 3000, well, 2875 to 3000, so we'll say 3000 watts. It's a 3000 watt kettle. So let's go. Well, this is good, isn't it? Look, it makes the Sony AX53 look enormous. Okay, so we're nearly done with the cold one. It's taken much longer than I expected. We're at 3 minutes 20 now. I thought it'd boil quicker than this. Clearly not. There we go. There's our time, 3 minutes 37.47, but I stopped it. My reaction times are rubbish, so 3 minutes 37 seconds for cold water. Let's do the hot. This isn't the sort of video I normally do, by the way, but I just thought, because I was going to do it anyway, I thought I'd video it and put it on YouTube. It's not really the sort of stuff I do on my channel, but it is my channel, so yeah. I'll put it in the other category, I think. There we go, there's our answer, 1 minute 58. Wow, that's loads quicker than I thought it would be. I mean, it makes sense, obviously, that it would be a lot faster, but that's a lot. That's a big difference. There's almost like 2 minutes. Anyway, let's go to the computer now and do some maths to see whether we can work out exactly how much we're going to save. Okay, so very little preparation on this one. So if I do get my maths wrong, please comment and let me know what I've messed up here. Okay, so we've got some assumptions to make. We know the kettle is rated at 3000 watts. It actually probably will vary a little bit, but let's say it's a 3000 watt kettle. We know that the cost of electricity, for me at least, is 13.06 pence per kilowatt hour, which means that if my kettle was 1000 watts, it would cost me 13.06 pence to run it for 1 hour, but it doesn't. It obviously, for 1 hour, costs me 3 times that amount. It costs me 39.18 pence to run my kettle for 1 hour continuously. But how often do you run it for 1 hour continuously? You don't, right? So this is the cold. These are cold calculations. 3 minutes 37, 1 minute 58. So let's put these into seconds, because we don't have to do any interval stuff then. 217 seconds versus 118 seconds. And here's where we have to make an assumption. Well, how many times do you boil your kettle per day? Well, let's say Well, it depends, doesn't it? Because not everyone uses kettles. If you're in the US, you probably don't even have a kettle. I don't know. It's far less of a common thing. In the UK, however, everybody has a kettle, right? Everyone. So I'm going to say 5 times, because I use it when I cook pasta. I use it if I'm making a drink, of course. I'm going to say 5 times a day, okay? I don't think that's unreasonable. If you're in the UK, I think you'll probably agree with me that that's not an unreasonable number of times. For anywhere else, maybe it is. I don't know. So we're going to multiply these up and say, well, our kettle, when we're boiling cold water, is therefore on for 1,085 seconds per day. And if we boil hot water, it's only on for 590 seconds per day. So at this point, we probably need to do a few more calculations around how much it actually costs to run the kettle. Well, we know that it costs 39.18 pence to run it for 1 hour. So how long does it take to run it for 1 minute? Well, that's pretty straightforward. 39.18 divided by 60. It takes us down to 0.65 pence to run it for 1 minute. And we're going to take that down even further and do how much it takes us to run it for 1 second. So there's our value to run it for 1 second. So now we can do, I'm going to highlight this column because anyone who watches this that knows me will know that I would like to highlight it in some random pastel color. I'm going to say this, I'm going to do that, multiplied by that. So, per day this is now, remember? Oh, that doesn't work. Ah, okay, so no, I have to do this one. Needs to be F4'd, doesn't it? Right, that's better. So, it costs us 11.8084 pence per day if we use cold water versus 6.42 pence. Right, so how much is that per year? This is getting really silly now. So we're just gonna obviously multiply this up by 365 days in a year. Quite a lot, actually. That's more than I thought. Versus 2,343 pence, and then we'll do our final one divided by 100 to give us our pounds and pence figure. So putting in cold water versus hot water, we just take this and take this off it. Saves us £19.66 a year. Now, £19.66 is not a massive amount. And you've got to think, well, okay, every time you run hot water, you've got to fire up the gas boiler. But realistically, £19.66 is probably what we spend on, that's probably like a whole half-month gas bill for us, for everything, you know, for all our cooking, all our heating, everything. There's no way that we spend that much by just running the tap for a few minutes. But of course, that's a bit of an unknown one in this particular scenario. So that's the figure that I can come up with. I kind of got an idea that if I've got my maths wrong here, I'm going to lose my job, because my job's kind of partially related to, not related to kettles and electricity, just related to stats and all that sort of stuff. So £19.66 is how much we'll save by using hot water versus using cold water. There you go. There's a figure in one possible scenario. Work it out yourself. You can use these stats, you can change your price on here, and just figure it out and see whether it's worth it. In my opinion, definitely. I will be using hot water from now on. There you go. It's exciting stuff here on tdcat.com. Thanks for watching. If you like, probably not if you like this, if you like our normal stuff, if you like my normal stuff on the channel, then please just subscribe to the channel or just comment below. It's good to hear from people. Thank you. I'll catch you soon. Bye.